Okay, this screencast accompanies this short PowerPoint presentation showing some other important ray diagrams. I lecture on this in class. Okay, first of all, we have here depicted what is called a compound microscope. A compound microscope is formed by using two double convex converging lenses positioned as shown. The first lens that is close to the object, for example, right here, say on a microscope slide, is referred to as the objective lens. The objective lens has two foci here and here. And then the lens that you actually look through is called the eyepiece. It's a larger lens that also has its own two foci here and here. The observer is over here on the right-hand side. Okay, so then basically what happens is the following. We have here an object like so, and then we have light rays coming from that object refracting through the objective lens and then forming a real inverted image right here in front of that lens. However, this image of the first lens, that then becomes the object for the second lens. And this object is closer to the second lens than that lens's focus. So then therefore, when the light rays pass through this first image and they refract through the eyepiece, refract through this second lens, they then refract such that when they emerge, the light rays are slightly diverging from each other. So then therefore, if you take these diverging light rays and extend them back behind the lens like so, they then look like they're coming from this point here. So then therefore you end up with this large upright virtual image. It's upright in the sense that the image here has the same orientation as this object here. Once again, the image for the first lens becomes the object for the second lens. And then we can calculate overall the magnification of this compound microscope, for example, by comparing the size here of the final image to that of the object. Okay, next let me describe three different types of common ailments associated with eyes. First of all, the most common type is nearsightedness, also known as myopia. I'm sure that a number of you suffer from this. For the myopic eye, if you're nearsighted, you can see objects that are close to you clearly, but objects that are far away are blurry. So we describe this by defining a point, what is called the far point of a myopic eye. In other words, if this right here is the lens associated with your eye, it's a double convex converging lens, as you can see. This then means that you'll be able to see objects clearly from this point here to this point. In other words, the light rays coming from an object like so would then refract through the lens in your eye and form the image here on the retina as it should. However, objects that are farther away from you than the far point, that's being depicted here in the middle of the slide, well, then those light rays coming from an object that's very far away from you will not be focused on your retina. Instead, they're focused here. So the way that we correct for that is to position in front of your eye a double concave diverging lens like so. That then takes the light rays that are coming from an object that's very far away, spreads them out a little bit as they pass through this corrective lens, such that when they pass through the lens associated with your eye, they then get focused onto your retina as they should be. Now, telling whether or not a person is nearsighted by looking at their glasses is actually really easy to do. So, for example, if you look through the glasses of a nearsighted person while that person is wearing the glasses, you will then see an upright virtual image of their cheek, for example, that is smaller than the cheek itself. So you're looking through a diverging lens. A diverging lens is the correction for nearsightedness. Okay, now a little bit less common is what is called farsightedness. I myself suffer from this. With the farsighted eye, you can see objects that are very far away from you clearly, but you cannot see objects that are close to you clearly. So the way that we describe this is by defining what is called a near point. The near point is basically the nearest that an object can be to you, such that the lens in your eye correctly focuses those light rays onto your retina. If you have an object that is closer to you like so than the near point, then ultimately your lens is going to focus an image behind the retina like this. So the way that we correct for this is basically to place a magnifying glass in front of your eye, a double convex converging lens. This then takes these light rays here in the middle portion of this slide and then focuses them like so here onto the retina as they should be. And then less common than that is what is called astigmatism. If you are astigmatic, this then means that yes, the lens in your eye correctly focuses the image onto your retina as it should be, but as you can see here in this slide, the image is distorted. So the way that this is corrected for is to use a cylindrical lens. With a cylindrical lens, because of the differing radii of curvature associated with different portions of the lens, This then ultimately corrects the distortions of the image such that it looks clear as it should here on your retina. Astigmatism is difficult to correct for. Each individual person has to have highly personalized lenses in order for the correction to occur. Okay?